And hello, welcome back to another 3D Hangouts. My name is Noel Ruiz. I'm a designer here at Adafruit, Germany every week. This is my NASA brother, Pedro.
Good morning, everybody. I'm Pedro's Creative Tech here at Adafruit, and every week we're here to share 3D printed projects featuring electronics from Adafruit.
That's right. This is where we combine 3D printing, DIY electronics to make inspirational projects. Hello, everybody, hanging out in the Discord chat room. We're going to give a shout out to everybody in just a few moments. We'll do housekeeping, and then we'll jump right into all the fun demos. Lots of fun, glowy projects this week. So yeah, if you want to join us live during the show, we have lots of GIFs and memes and fun stuff going on in the Discord chat room that you can get there by hitting up the URL discord.gg/Adafruit. Yeah, and then we're in the live broadcast chat room. Live-broadcast-chat room. Pedro, welcome everybody in the chat room to the show, please.
Good morning, good evening, good afternoon, good night to everybody hanging out all over the world. Giving shout out to everybody hanging out in all of the chat rooms. We got Dean, we got Rolls, we got Unheard Grace,
Hello.
we got Paul Hunter, we got Jim Henderson,
Hola.
Rosin, Duester, Yanni.
Shalom.
Good morning to everybody hanging out all over.
Shout out to Yanni, posting up all the neon signs.
Really good ideas.
Yes. We have lots of neon signs this week. So yeah, we're gonna do the housekeeping and then we'll jump into our lightning bolts. So let's run through this stuff, shall we? First up, we're gonna head up Adafruit.com/free and see all the different freebies that are going on while supplies last. We're still living through the chip shortage of 2022, and we're gonna have these freebies until we can't. So these are great. So check these out. So the first tier is for orders of $99 or more. You will receive a Perma Proto half-size breadboard PCB. And for orders that are $149 or more, you'll get the half-size Perma Proto PCB Plus and Adafruit Stemma QT Breakout. If you have an account with Adafruit, we'll make sure you don't get the same one twice. And then the third tier, for $200 or more, you'll get the Stemma QT Breakout, the half-size Perma Proto, and free ground shipping from UPS for continental US only. So check this out, Adafruit.com/free. These get automatically added to your cart as you add things to your cart. So you don't have to do any special coupons. Yeah, you can get all of the freebies. So yeah, limited time only, yes, in very small text. So check this out while the supplies are lasting. Okay, let's head over to the jobs board and find out some jobs that are wanted this week. I'm seeing some new positions. A contract gig for the Burlington, North Carolina area. There is some CircuitPython RP2040 positions, particularly. It's in the job title, so check that out if you are in the market for a new gig. Could be a side gig here, but that's the latest that I'm seeing here in this month of May. So check those out at jobs.adafruit.com. It's free to do so. You can post up your resume or post up a job offer. Sweet. And that's the jobs. We want to promote the newsletter that happens once a week. By hitting up adafruit.com/newsletter, you can subscribe to get notified when all the new stuff gets added to the Adafruit shop on the weekly. You also want to give another shout out to Ann Barella and the rest of the CircuitPython team for doing up the Python on Microcontrollers newsletter. Shout out to all 9,000 subscribers who are subscribed to it. Very cool place to get all the latest stories and happenings in the world of Python on microcontrollers. Cool. Shout out to Paul Cutler for doing up the CircuitPython Show podcast this week. We have a little bit of break, but next week, special guest Liz Clark is on, I believe.
Nice.
But definitely check out Melissa's episode. It was really nice to tune in and hear her story. So shout out Paul Cutler and subscribe to that podcast on all the fine podcast services. All right. We ready to jump in?
I think so. Let's go ahead and jump into this week's project. This week we have very awesome neon lightning bolts.
This is cool. So I've been wanting to make a sign using these neon style NeoPixel strips, and we actually kind of already have. So we'll take a look at the previous stuff. But for this project, the goal was to make a simple sign with some constraints in mind. So the idea was to, let's make a sign, it's 3D printed, and it takes up the whole length of the NeoPixel strip. These NeoPixel strips come in 1 meter, so that's a full meter, and they have 96 NeoPixels. So you get plenty of NeoPixels to play with, a little bit under 100, and you have this really nice silicone diffusion. And what you can do is you can cut this up and you can splice it to make all sorts of intricate shapes. But the constraint and the goal here was to, how can I make a sign with just the stock LED strip? No cutting and no splicing. How can I make a sign that will look cool and kind of have this neon, look to it? So we came up with a couple of different signs. This is a lightning bolt with 3 sections. And I really like this one because you can kind of see where the limitations present themselves, particularly in angles. So if you're making a sign with this neon style NeoPixel strip, you want to consider the angles. So here you can see in this lightning bolt, you have these really sharp 90-degree angles, and unfortunately you are limited to the thickness of the strip. So the strip is about 4.5 millimeters thick or thin. And with that, if you're making something with sharp angles, you kind of want to add some corner radiuses to your design. So here you can see I have a corner radius, but it's not really conforming to it because it's just the nature of the thickness of it. You want to be very careful with buckling, or rather just kinking this. You are able to damage it if you bend it too much. So if you just bend it in the right spot, you can break the internal strip. So be very careful with that. And with that in mind, you can create some really cool signs. Just consider, the corner radius, which is about 10 millimeters. We'll take a look at the CAD stuff in a few moments, but I just wanted to highlight some of the things real quick about this NeoPixel strip. One of the cool things about the strip is it comes with a pre-soldered wire connection on both ends. So what I was able to do was just cut off the connector end from the end of the strip and then wire that directly to our microcontroller of choice. This week it's the RP2040 QT Pi. So this is a small little cheap dev board that's really, really powerful. It's running Circuit Python, so you can have the LED animation library, which is running here, and just string together all sorts of fun animations. So this connector is great because it has this really nice latching bit, and you can disconnect it easily by doing that. It's got a little tab that you just kind of press down, and then you can connect it back like that. It's keyed, so it only goes in one way, so you're not going to do it wrong. So that's really nice. You don't have to kind of create your own wire dealy. It's already kind of included here. And what's even cooler is our latest batch of strips come with labels on them. So here you can see it tells you what the red and the green and the black are. DIN, that stands for data in. So this is the connector that is the first NeoPixel. It goes all the way across. And then it comes down to the end of the NeoPixel. You can see here DO is really data out. And this is the connector that you would chop off and wire this to your QT Py or other RP2040 board. Obviously this is a Disney Mickey sign. It's just one of the things I was making. I didn't release this one for obvious reasons. Don't want to get any copyright stuff. So that's just looking at the stock neon LED strips. So that's really cool that they come with these labels now. I didn't know that because the ones I had on hand didn't have that label. So in the guide we'll show you, you can tell which one just by looking at the connector. The one with the latchy bit is data in. Latchy bit, data in. So let's take a look at some other designs. I wanted to make a bit of a rainbow, and one of the things with the rainbow, I just made it a continuous shape, so it just kind of goes around it. So let's go ahead and plug this in. So with this connector, they're all the same connector, so that means that you can easily swap these out by just disconnecting it. I really like that feature. So here you can see the rainbow has a nice radius here, so we don't have any problems buckling or kinking here. and this takes up just about the full length, the full meter long length of it. You'll notice here I actually trimmed away with some scissors and then a hobby knife. I've trimmed away the kind of end cap bit here. You can see there's a lot of silicone there. So you can use a hobby knife carefully to kind of remove that if you want to use the whole strip length. But there you can start to see where the actual flexible PCB is. But yeah, it fits in there nicely. And another thing to note, you'll notice that there is some extra geometry here at the bottom, and this just creates a compound shape so that these pieces aren't flopping all over the place. So with the lightning bolt, I kind of was able to merge these two ends at the bottom there, but if they weren't merged, you would have some floppiness to it. So there's another design consideration. If you have a piece that's kind of out there, you kind of want to add some material to the design so that it makes it more sturdy, so that it's not going to just fall apart. So that's another design tip. Here's the cat. This is kind of a silhouette of a cat, and you'll notice that the channel here kind of does the same dealy, where it just goes into a single shape. But then at the end here, I added a little bit of a connecting bit here to connect this to that, and I still have a nice exit hole for the strip to kind of come out of. So yeah, those are some quick looks at the signs and some tips on what to consider when designing a sign with these constraints. Yeah, Blink is back there. I was like, where's the other one? Oh yeah, she's back there. So it really depends on, like the sign depends on a couple factors. For me, I wanted this to take up the entire bed of our 3D printer. Our 3D printer is fairly large. It has a bed of 300 by 300, which is like 10 inches, right? So it's fairly big. So if you have something, you might want to scale this down.
I think it's 12.
You think it's 12 inches? Okay, it's 12 inches. You might want to scale this down or just kind of re-massage the sketches. If you want to use Fusion 360, you can take the original designs and kind of try to scale it up, or make one from scratch, which is cool because I'll show you folks sort of the tips on how to use Fusion to make a custom sign.
All right, let's pause here. Take a look at the chat room, inspiring our watchers here. We have Seeker, who is saying that they're working on a Pikachu-shaped neon-style light, and this is a perfect reminder to get them to finish it off. Yeah, right before the show we were joking that it looks like Pikachu's tail.
Yeah. With the lightning bolt.
So this would be a perfect, one thing that you didn't mention, perfect for cosplay. Like you could actually add some little tabs on here and like sew them on, or maybe just a necklace to adorn that on your costume.
Yeah.
It's a really good way to have a portable neon-like sign. Yeah, that like hats.
Mickey ears is
the Mickey
one
ears.
we did before.
Oh yeah, that's
We'll
exactly what we use for the Mickey ears. And then one of the questions too from Vince is asking how cuttable is the strip, and we'll cover that in a. We've actually did a whole guide on that exact thing with the exact same strips. We'll show you what the pads on there look like. They are very friendly to cut up and reattach, make different shapes.
Yes, that's very true. Cool.
Yes, and Rosin is saying that the radius on the cat ears looks very tight. Yes, we'll go over what the maximum diameter or the radius is for the curves, and how to measure that out.
Yeah,
John, Joan is asking, yes, these are reprogrammable. These are just NeoPixel strips.
We'll take a look at the code and
what it actually looks like underneath the sheath and the diffusion that is creating that nice, super soft.
Yeah, I love the LED animation library because the stock animations are just so easy to string together. You can customize the spacing and the speeds of whatever animation you want to play with. So that's really cool. So let's I guess drop into the Learn Guide. We'll walk through it a little bit.
Do we have just a strip by itself? Rolf is asking, how do you bend the neon tubes? They're not neon tubes. They are strips.
What happens in my overhead? It went wild style. All right, so what I'm gonna do is do a quick demo of taking out the strip. Yeah, so it comes with this this little tie. You can take that off.
Oh yeah. Oh.
Yeah, isn't that cool? So yeah, this just press fits in. The silicone is
So it's not a
grippy.
tube. Not
yeah,
a tube.
It's not a tube. You're gonna see the whole strip. I'm just press fitting it out, just removing it. The silicone gives it a nice grippy grip. But this is what the strip looks like. It comes in a nice little coil when you get it. It'll kind of look like this. It comes in a nice ESD safe bag. But yeah, you can flex this guy. It is fairly thick. You're looking at 6.5 millimeters thick and about 13 millimeters tall. These are the end caps there, so they're a little bit bigger. But this area here is where the LED actually is. So here's a strip. You can kind of see where the strip can be cut. You'll want to cut it at these little markings here. This area here is see-through so that you can see where to cut it. But these are the segments here. So right here and right here would be one LED, I think. Is that right, Pedro?
What's that?
Is this one LED, these two segments here?
I'd have to go look. I don't remember.
I don't
but
remember,
I believe
yeah.
it
But there's
is.
96, right?
I believe it is.
And
Either that
as
or
you
two.
So we're going to insert it into the cat now. I recommend doing D out. This is the last strip. So if you wanted to connect multiple strips together, you absolutely can. You would just connect this bit to the other in the D in of the other LED. So you can totally chain as many as you want together. But yeah, so to install it, you want to have this being the front face. So why don't we just go ahead and connect it back to the microcontroller so we can get a better look at it. What happened to the microcontroller? Where did it go? It's right here, connected to the rainbow. All right, so let's go ahead and connect it up so we can see the light glowing. It should be safe to install while it's on because we're being very careful with our bends. So I'll start with, adding this end here to the tail. Press fitting it in, and then just kind of molding it in there, being cautious of your bends. The wall thickness of the print is just about the right length to be all perimeter and no infill, so that makes it really strong. So as I'm getting here, I'm being really cautious about press fitting it in and just kind of getting that press fitted in there. So that's, you can see here that you're not going to conform those really sharp angles until you like press it all the way in. And you can see here, yeah, it starts to kind of lift up slightly, but that's okay because we're not too excessive on that bend. And then closing it off, you can see here that I'm actually have a little bit of excess, so that's just fine. So you can leave that there. Whoop. Or you can cut that if you'd like, but I'm not going to cut it because then I'd have to reconnect this wire here. Or you could cut, make this start over here, however you want it, right? But this is just like kind of seeing how to install it and thinking about it. At this point you can cut this off here and kind of clean it up, but this is just me leaving it as a stock thing. And then another thing to consider is like, do you want your sign to be hung on a wall or do you want it to stand upright? It's kind of challenging to make it stand upright just because of the shape. I was able to get it to stand upright. Yeah, it's kind of hard with the cable kind of all over the place, but it does stand upright. Depends on your shape, right? The lightning bolt won't stand up right, but the Blinka does. You can see here in the back there, she ends up standing up okay. So yeah, so that's a quick look at installing it. Pretty easy. Take it out, put it back in. You don't need to glue it in place unless you'd like. I didn't. It's just kind of grippy in there. But yeah, that's how the corner ended up working out. So there's the kitty cat. Okay, that was cool. We got a good look at setting it up. Any questions about that?
Yeah, so far, Joan is asking, or just commenting, there's would be a really nice array of these for a art light installation.
Yeah, this is just one. So imagine doing one letter on, per sign, and then kind of doing a whole word or a whole sentence. So you can really scale it up. Yeah. But yeah, it all kind of depends on the size of your 3D printer, the bed, because it's all printing flat. There is some ways to get a little bit more length out of your printer when you do diagonal.
Which we'll show that
Which I'll
in
show
the
off.
printing section.
In the
Another
printing
comment
section.
over by McGruffin is saying that they prefer these over EL wires because the inverters scare them.
Yeah, the inverters they can be annoying.
The high-pitched
They
noises.
can be annoying, and I never get brightness. The
The
brightness
brightness,
out
you
of
cannot compete with the
out
brightness.
of EL is so not bright, unfortunately. But
Yeah.
this is only 0.8 of so 80%
Oh,
brightness.
yeah,
So you can make
yeah.
this even brighter.
Yeah.
I've toned it down for the camera, but you can make that really, really bright. Again, 96 NeoPixels in here, so you got plenty of pixels. Here you can kind of see in this rainbow chaser how you can create cool separations. And you could make this audio reactive using our code for this guy here with a PDM microphone. Remember our little VU meter? You could do the exact same code and then just wire up the microphone to this, and then you'd have a reactive neon sign. So that
cool.
could be a neat one. Maybe you make a cool shape of a record player or turntable or something iconic.
Mhm.
And then make it audio reactive. That'd be a really cool one.
Some shape like Mr.
What shapes
Mr.
we got?
McButt Pants is saying that continuous looking signs will make RGB monitor TV backlighting look so much better.
Yeah, so you can adorn mirrors and other type of signage on your wall or wherever to make really cool accent stuff. Outlines and silhouettes of your sign or whatever.
And then what MCU is recommended for
MCU.
this?
That's the
They know C++
Marvel.
and micro and I'm gonna guess this is MicroPython. Yeah, MicroPython.
Yeah, we have MicroPython support for the Py RP2040. That's this. How much is it? $7 or is it $10?
They want to drive 8 of these in an array. So maybe something with more pins. Maybe the
Yeah, I would
Pico?
recommend a Pico.
a Raspberry
$5
Pi.
Pico,
Raspberry Pi.
RP2040. Yeah, that has enough pins definitely for controlling multiple strands for sure. We also have some dedicated hardware if you want to do more than 8 channels. You can do a bunch of channels with our is it NeoPixel 8? I think is the one if you want to do some hardcore NeoPixel chains. Yeah, all good stuff. So let's jump into the Learn Guide and take a look real quick at some of the stuff. We do have these in stock right now. It's about $35 for this meter of neon-like skinny NeoPixels. Yeah, so it's meter long, 96 pixels, very, very beautifully diffused NeoPixel strips. The RP2040 is $10. It has, I think, 8 megabytes of flash, so you can have all sorts of code and libraries in when you're running CircuitPython or MicroPython. And we have a power supply as well, a nice little cheap 5-volt 2-amp power supply, and a micro USB-C cable. Type C to Type A USB, and this is a nice long one, so if you're doing a sign you're going to want a nice long one, and this is like a nice pink woven USB cable, so
It might match the your color scheme.
Yeah.
And then real quick, you can go jump into the product page for the silicone NeoPixel strips, silicone, and they can tell you there the current draw per meter. If you want to check out the specifications. Or the data sheet is linked right in here. There we go.
There it is. And it even tells you the connector type is a 3-pin JST SM. Here it is. Here are the folks that make it. iPixel LED light. It's got some sort of IP rating of 65, so it's a little bit water splash proof, whatever. There's some more stuff here.
Wattage per meter is about 13 watts a meter.
Oh, it is 12 millimeters tall, 6 millimeters thick. I mean, for me, I made a little bit
Got 96 pixels
6.5, so you
per
have a little
meter.
bit. Yeah, 96. There's some wattage stuff here, 13 watts, temperature, operating stuff. This is a nice, look at this data sheet. This is really,
An
really
actual,
nice.
yeah, that like the drawings.
Really
and
nice.
You rarely get so much detail.
Oh, they even have like
the accessories.
Yeah,
what?
I've never seen that. Front caps and end caps.
Huh.
Oh, look, they even tell you the bend. Nice. Don't do it this way.
There you go.
60 millimeters.
Okay.
Well, I'm a little bit.
I think you're doing like 30, huh?
Yeah, incorrect bending way. Yeah, you don't want to bend it that way. Here's some power supply
nice.
stuff.
Very cool.
How to daisy chain them.
Yeah, the user doing the array.
This is a great data sheet.
This is
y'all
great,
yeah. Awesome. I didn't even look at the data sheet, y'all, because normally there isn't one.
Dude, yeah. Well, even if there is one, it's like in a different language.
Well, you know, I guess 60 millimeters, that's a lot, man.
That's a
y'all
lot.
saw, you know, y'all want to be careful. I don't want you to break yours, because I did break one. Because I just flexed the crap out of it, particularly with the lightning bolt. The lightning bolt, if you're going to flex the crap out of it, just be very, very careful when you're doing those bends. So you can get away with it, but the data sheet warns you 60 millimeters, that's a lot.
Mr. McButt-Pants is saying current is 2.6 amps a meter, so 2 amp supply on Adafruit won't drive a full meter.
I mean, it's doing it now.
Is this some sort of magic illusion that we're doing?
No, it's just because it's not using like the full...
The brightness.
Yeah, if you were to do full white, I suppose you would probably cap out and would probably tell you, hey, I need more. Like the CircuitPython will warn you and tell you, hey.
I mean, this is only like 5 volts.
Yeah, it's only 5 volts, 1 amp out. But yeah, that's... Yeah, normally you're doing colors and not using all 3 of the 96 colors to make white.
Good point, good point.
I could try that, but yeah. Maybe just turn on the brightness. But yeah, you can pick a bigger power supply. I think we have a USB
adjustable
power supply that's adjustable, so you can give it more amps. But you want to stick with 5 volts. Cool. All right. Moving on. Let's look at the circuit diagram. Pretty simple. You got 3 wired connections, voltage, ground, and a data pin. You can swap out the data pin for any of the available data pins. But you want to use the 5 volt pin because it's using 5 volt logic. So there you go. The strip's like 5 volts. CircuitPython's fairly easy to install on any of the RP2040 boards. You can get into the bootloader and then drag and drop a UF2 file that you can download from the site, and it'll automatically flash and install. And then it shows up as a flash drive on your... What's up? Oh, thanks. Yeah, so here in the Learn Guide, do we need to go back to the circuit diagram? Or skip it?
Yeah, skip it.
All right, well, there's a circuit diagram, really easy. You can download Fritzing and get some Adafruit parts to make these type of wiring diagrams. It's drag and drop. It's really nice piece of software for doing these wiring diagrams. Installing CircuitPython on any of the RP2040 boards is fairly easy to do. You get the board into the bootloader mode using the boot and the reset buttons, and then you can just drag and drop the UF2 file to automatically flash and install CircuitPython onto your RP2040 board. Then it shows up as a USB drive. You just drag and drop code and libraries and assets, like if you had bitmaps or WAV audio files, you just drag and drop. That's one of the beautiful things of CircuitPython. Okay, and then into the code part. This is cribbed code from one of the demos for the LED animation library for CircuitPython. Here you can import the various effects. Here we're using the rainbow, rainbow chase, and rainbow comment, as well as the animation sequence module, which allows you to string those animations together. Then you want to set up your pin and tell how many pixels you're using. And then here, when you create the NeoPixel object, you can tell it how much brightness. By default, I have it set to 0.8. Maximum brightness would be 1. And then here in these next lines of code, you can customize the animations. Each animation is going to have its own parameters that you can modify. The rainbow has speed and period, which you can change, how long and how fast. And then the rainbow chase allows you to change the speed, the size, and the spacing. And then the comment allows you to change the speed and the tail length. And then you can tell it either to be a true or false on bouncing back and forth if you want that effect or not. And then in the animations array here, you can see I'm just stringing them together. And then you want to say how much of an interval do you want. I want each one to last about 5 seconds. And then you can do auto clear. And then in the loop, I'm just saying animations, animate. And then it just runs through those in that list, in that array. There is lots more information on the LED animations learn guide, which is a prerequisite guide. If you look here in the list of prerequisite guides, CircuitPython LED animations library guide by Kattni Rembor has all of the things that you would ever want to know about animations. So here under the rainbow section, you have all the kind of parameters broken out for you. And there's some other ones that you can do like step and some other things. So check them out. You can even reverse them apparently, which is super cool. So definitely check this out if you want more customization out of the animations. It even shows you how to do matrices. So if you want to do something like this, do a whole grid of animations. Yeah, and there's some other ones that I don't have here, so you can check those out. Yeah. Okay, let's go back to the code. So that's the code in a nutshell, pretty simple. Here's a screenshot of what your CircuitPy drive looks like. Your code is a Python file, and your libraries are in a lib folder. Yeah. When you use the download project bundle, it downloads all the dependent libraries, the dependencies. So it's one zip file, and you just drag all those file and folders into your CircuitPy drive, and then you're ready to go. So that's a really cool way to do it. Instead of having to manually grab the libraries from the bundle, it all comes here in the project bundle. Excellent. The next page shows you just some notes here on wiring up the strip. So kind of locating the in and the out. Luckily, the latest ones have labels, but if they don't, this is a good way to kind of to know which is which. We're basically cutting off the data out cable and wiring it to our QT-Py. We got 3 wires for ground voltage and a data pin. You can power it off with a 5-volt USB battery, no problems. It seems to work just fine. All right, now onto the 3D printing section. I have some slice settings here, like nozzle and bed temperature, but it's going to vary on your style of PLA. We recommend PLA. You could use something else like PETG. You're going to print a little bit hotter with PETG, but PLA is safe bet. The build volume, right? The size of the bed should be a minimum of 300 by 300. And here is a screenshot of our lightning bolts. To kind of fit that, I basically just rotated it 45 degrees on the bed. That way you can get a diagonal length. Diagonally, you get a little bit more length out of your printer. So the file. And here are all of the available designs. Cat, lightning bolt, rainbow, snake. Right? Cool. So now I'm going to jump into Fusion 360 and then take a look at a little bit of a CAD chat. You want to post up a Twitter?
Yeah, this is a really good way to visualize how long your shape can be to accommodate the entire meter strip.
Exactly. So here I got a sketch, and in this square I basically sized it to be the bed of my 3D printer. It's 300 by 300. So this gives you a good representation of, how my design will look like on the bed. So if you have something a little bit smaller, like 250 by 250, you would see, would this design fit? Let's update our dimensions and see, would this fit? Yeah, it would. This would actually fit. So what I've done here next is I've made a series of lines, and then I connected those lines with these arcs. So one thing that's cool is when you click on a line, a sketch line inside of Fusion 360, and if you scroll down to the bottom here, it'll tell you the length of that line. Currently, that single selection that I made is only 110 millimeters long, but if you double click that line, it'll select the whole chain, the whole path, and that gives you an idea of the total length of your path is about 974 millimeters. Now, when I was designing the signs, I know that my strip is 1 meter long. That's 1,000 millimeters, but those end caps aren't going to fit through the channel as you saw me install. So you want to make it a little bit under. You want to make the total length under if you don't plan to cut off those end caps. That's just one tip to know. So double clicking your path, your sketch curve will tell you the total length. So it's 174 millimeters with some change. Cool. Now I'll go back in the timeline to kind of show off how I designed it, what feature I used. So if it's just a single line, you can use the extrusion, the thin extrude.
Oh, the Fusion screen is not,
it's not
up.
Oh boy. Thank you. Womp, womp. All right, let me kind of redo it. Not redo everything, but kind of. All right, so in Fusion 360, you'll want to create a sketch that is the size of your bed of your 3D printer as a starter, just to let you know, is my sign going to fit in my bed? My sketch was 300 by 300, but I dropped it down to 250 to 250 just to show that this still fits. And then what I was showing was if you select one line, you'll see the length of it down here at the bottom right corner. You'll see it says length of your one sketch line is 110 millimeters. If you double click that line, it'll select the whole chain of the path, and that gives you a total length. So it's at 975 millimeters roughly. So that gives me an idea that it should, the sign should take up the whole meter length with some change, and you want that change if you want those end caps to kind of be there. So that's why I'm trying to make it a little bit under the full meter. Okay, so to extrude a single line like this, you can use the extrude feature, which is the most basic feature in Fusion 360, but there is a type. So normally you do a regular extrude, right, to a profile, but the thin extrude allows you to select a line, a single line. And the main thing I did here was made my wall direction center based. So if we look at it top down, you can see how the location from one side and two side are rather different, but then the center will flare out your extrusion and keep your path in the center line of your total extrusion. Another thing is that it's 12 millimeters tall, and the wall thickness of my extrusion here is 9.6. That's accommodating the thickness of the strip plus 1.2 millimeters on each side. So that's kind of how I'm doing it. You could do a user parameter if you want to make it a little bit more easier, but I have a fixed value here just for kind of simplicity's sake. So after that, I make another extrusion using the exact same path, but this time I've reduced the wall thickness from 9.6 to 6.4. That 6 millimeters is the thickness of the strip, but that 0.4 millimeters is just to give me some clearance so that it's not so tight on that strip. It's I'm also doing an offset of 1.2 millimeters so that I have a little bit of, you want to have a bit of a backing to your wall, to your channel. So that's why I have it offsetted here. The operation is cut, so I'm cutting away, and I'm using the same tallness, so it's 12 millimeters tall. And then the wall thickness is just different at 6.4. But as I'm holding down the command on Mac or Control on PC, you can kind of see how this cut is kind of just following along the path. So that's kind of how it's doing it, right? And then from there, that's kind of it. You can see my wall thickness here is 1.6 millimeters, actually, not 1.2, but 1.6. It's just a little bit chunkier. Normally I do 1.5 millimeters, but 1.6 here is because I've updated my my extrusion width. So that's just one thing, but y'all can change that as you like. So yeah, that's just a quick look at that. I want to show off some of the other things here. So some things to consider for the cat. Here's what the sketch for the cat looks like. Again, it's a, let me do show dimensions. Can you see my screen and everything? Everything's good there? Right?
Yes.
Good, good. All right, so for the cat, you can see I combined several paths. For this one, you can see as I'm double clicking, it's not doing the whole one, so I have to hold down shift to select the entire group here. And the total length here is 884 millimeters, so a little bit under. So it could add some more to it or not, but I found that that's okay. So you'll notice that in the sketch, I don't actually connect the line together. So after I extruded it, I'm left with this, right? And when I printed this out originally, it was really, really floppy because, you know, it's just a single kind of path and there's nothing really kind of holding the structure together. So what I ended up doing was just sketching out some additional lines like this. I projected in the extrusion in its own sketch, and then I added these lines to connect these points. That way I have a profile that I can then extrude and merge into my shape, give it a little fillet to round it off, and now you have a compounded shape that has a little bit more sturdiness to it. So that's one tip there for that one. For the Blinka one, I ended up doing the same thing here on this end. I just added some more lines and added a little fillet there to combine these two ends so that they're a little bit more sturdy. For the rainbow, very similar. Added all this stuff here to the bottom to close it off and make it a compound or sort of manifold shape. So that's the rainbow. And then the lightning bolt, same thing. It's kind of like Blinka. The tail at the end kind of joins and merges into itself. So that's cool. Now, one thing to note about the lightning bolt is the lightning bolt actually started off like this. So you can see here my paths are very, very jagged and sharp. So what I ended up doing was just adding fillets to all those very sharp corners section by section. So kind of starting off with the internal corners and then the exterior corners, and then doing that for the adjacent corners. So I kind of added all those fillets. And as you saw, you know, I didn't even... My radiuses here aren't even enough. Like, they need to be bigger. But as you saw, with a little bit of extra slack, your strip will just fit in there. So I also have a screenshot in the Learn Guide that shows that. But yeah, there's some quick CAD tips and a quick walkthrough of some things to consider if you're designing your own in Fusion 360 or other apps. Any questions?
There was one.
Here's the Mickey one.
Charles Brandon Ford is asking, what can we use to plug up the ends of the strip that you cut into pieces? I suggested that you could use hot glue to seal.
Yeah, hot glue sticks really well to the silicone.
Mm-hmm.
It's hard to take it off though.
Yeah. When you cut it off, when that's snipped off already, you know, they're pretty separated, so they shouldn't interfere with anything. But like I said,
short out or anything?
Yeah, like if they're close together, then yeah, maybe add some hot glue, like just a little bit to seal it off.
A little dribble.
That or the
tape.
E6000 or
E6000 and some tape.
Mm-hmm. And that should do.
Or you can
otherwise,
print your own cover.
yeah, you can print a cover.
Yeah, they apparently have those accessories.
Yeah.
Sweet, good stuff. Let's go back to the Learn Guide. Wrap this up here. We're getting close. So yeah, this shows you me installing it. Yeah, so look at this photo. As you saw, the strip won't conform to very sharp angles. So in this lightning bolt, you can see just how much deviation it has. Is that the right word? I hope so. And a nice warning here, excessive flexing and bending can damage the NeoPixel strap, so be careful. And that's it.
One thing, do we go over how they look like when you actually cut them up and the pads?
Yeah, that's right. So a Learn Guide.
Do we have a completely different Learn Guide for this one?
Yeah, so this was an idea from Pedro, is to take a Lego base plate and make little clips that just hold the strip in place these little clips have like the connecting studs for the Lego, and they just plug into the Lego bits, and then these little clips, you just press fit the strip into the clips. But Pedro made it so that you have to connect these letters. So this is like a busy sign, and you can see how like the Y is two strips joined together, but the whole word is one continuous strip. It's just separated. So we'll show you here.
Jump into the assembly page. You can see what they look like when you cut up each one. There it is. The
watch
pads.
the video. It's actually really good in the video. You do a live.
You see a lot more of it actually being
actually
cut up.
Cutting it.
As you can see there, how I am exposing just the back side, but leaving the front side, so you still have that diffusion that's attached on the other side.
Yeah, and these markings here, plus is voltage, the minus is positive, and this is data in, the little I there. But yeah, you would want to use a hobby knife or an X-Acto knife and just to trim away, but leaving some of that.
Yeah, I actually use the flush cutters.
Flush cutters, okay, that's a better idea.
The length of the blade is perfect for getting that. Just enough to expose the pads that you're going to need with a little bit of slack, so you can get your soldering iron in there. And you can see there that you want to leave up on that that top part that's diffusing everything. Right here, you want to leave that. You want to remove just where the pads are.
Right. You want
and those
to be
are soldered
strategic
together.
about it, yeah. Cool. And, yeah.
And then you can see here that they are going in. Speaking of strategic, you want to cut them so they flow in the way that you want it, like from going from the B to the U to the bottom of the S and up around, and then to like the little edge of the Y, and then finishing off into the tail of the Y.
Right.
So that's another way you want to take
like
a look at how is it going to flow.
It's almost like your finger drawing it.
Exactly.
So that flow is really nice. And as you see in the sign or in the GIF, it really shows it. I should probably play this video. See if I can get it running.
And then,
it's a really good video. I was like watching this. It's great.
For these, when I cut them up, I didn't add any like dabs of glue or anything, just because they're not touching.
We have broken Safari.
I could just post the link to
Yeah,
what the,
sorry. Like Safari is just like, nope. I'm gonna just
too many
stop.
tabs.
I will stop working now. You have a PDF loaded. Yeah, it's all busted. Sorry, folks. The Learn Guide's heavy on JavaScript. All those movies. Every product is like a movie. Yeah.
Huh.
But yeah.
Right, link to the guide.
This is our third project that we've done with this NeoPixel neon-like
There's
LED
a
strip.
good one that we haven't done.
Here's the
Adafruit star going in.
Here are the Mickey ears.
Oh,
very
yeah.
cool. They are also spliced together, so you can see in the assembly how Pedro actually exposed it a little bit to go inside of the hat. That's very strategic, because then it gives you more ability to wire the damn thing. But yeah, this was really fun and cool as well. This was on a Gemma M0, I believe. Yeah,
And with MakeCode.
and with MakeCode. Yeah, you shook your head and it did a different animation. It's very cool. It's one of the best Disney strips we've had with this one.
Post a link to that one, since you're already there.
And where the
Discord,
yeah. Get rid of the assemble part. Discord. Yeah, so neon strips. Neon-like. Because it's not. Somebody in the comments said like maybe we should start a new terminology and call it Leon.
Yeah.
LED neon.
I like it.
You guys like Leon? Where am I? Here I am.
I think that's it for this week's project.
Yeah. Yeah, it was supposed to be really simple, a good lesson in like designing with constraints in mind and what's your end goal. I didn't want to do any of the complex stuff, so that's why I made it simple. But hopefully y'all can take this as a jump off point and make some really stellar signs.
All
I
right.
still kind of want to finish up that Mickey thing because like
Oh, yeah.
cool to have it.
It's funny, that's what the designs that just dropped this week is the Mickey balloons.
Yeah, and
That's
you'll
the
see
theme.
a lot of. I just remembered. You'll see a lot of these signs like at Target stores like Target, they have like simple signs like that.
Especially the
so I didn't want to do
rainbow.
Yeah, they have the rainbow, but it's like cut here in segments. So I was trying to figure like how do I make it different than Target. So that's why I went with the different lightning bolts and a different rainbow. And the Blinka. Blinka is really cool. Although she is kind of detailed. How do I capture a shape with like the most simplest of shapes? And that's what I got. I got Blinka there.
Looks like we got 10 minutes left, so let's go ahead and just jump into this week's community make since we had to skip it last week.
Yeah.
Since this one's so cool, we have to show it off.
Right.
No, the one from last week, but this one's pretty
just
cool
to
too.
Skip all of this. Skip all the videos and just go straight into it. All right, so community makes this week.
Very awesome because it is CircuitPython's birthday, right?
It is.
Yeah, I think it was like
or is it
last week.
Birthday?
MicroPython, yeah.
Some Python's
We all got Snake icons, so I was like, this is perfect to print out this super cool Snake storage with the quantum filament, so we can really show off the effect that it does.
Two-tone PLA for matter
Yeah,
hackers.
so you can see it
Great
going
stuff.
from purple, which is of course Blinka's color,
to gold.
down to the gold.
Great contrasty color.
Yeah, and I really like the detail of all the
Scales.
scales. And on the inside, you can see you have plenty of room
Is
for.
the head separate?
The head is separate.
Okay.
So the head comes right off, like.
Oh, cool.
Nice little way to
Nice
attach
connector
that.
bit. No
It's
supports,
separate.
huh?
I am impressed that the filament keeps going with the head because I did realign this for the time lapse. I had to just rotate it in a different way, so I didn't know if the alignment of the filament would continue. So super surprised with that. And this could also be like a planter if you had like a drainage hole.
That'd be cool.
But nice, simple, super themed storage for all of your. What we're using it for is like your tweezers and like pliers and whatnot, flush cutters, all that. All the tools are used around 3D printing. So nice Snake here by
3D Neato.
Yeah.
It's Neato. Here is the site. It's on Cold 3D. It's a free download. Is this different, Pedro?
I think that's a different one.
That's what's linked in the YouTube video, sir.
Whoops.
So we'll
I
fix it
believe
later.
this is. It's the same person, right?
Okay. I don't know.
Go to their designs.
3D Neato. Yeah, it's the same designs. It's just
Yeah.
different STL. It's a paid though. It's not free.
Yeah.
So it's
I don't remember paying for this.
Okay, well, I'm just telling you what the website is.
Yeah.
And the website says $2.
Yeah,
so
I don't remember
so
paying for
purchase
that.
for $2 and support the artist because it's a really cool design. And I guess there's some info here on dimensions and stuff. Very cool. Yeah, support the designer. So support.
And then the head even
Neato.
comes as a. Maybe I did pay for it.
I'm pretty sure
I
you
don't know,
did.
I'm not sure. But it also comes with like the eyeballs, so you can print this out separately or do like a multi-material print.
Cool. But we'll update that YouTube video because we got the link in there. That's fine. Cool. And then we have the Sea Dragon from the week after.
Sea Dragon, definitely a
Another
paid.
Pulse 3D. Sea Dragons.
This thing is so freaking cool. We had to print two of them. Different color than the one that is in the time lapse because, of course, it failed. Even with the Z hopping on,
Any
it just
tips
knocked
on
that off.
Why it failed, or
I mean, it prints with
Don't do
the
time
what are they called? The flippers. It prints with the flippers up. So as it's moving across, you're
it
gonna
did a
strike.
Oh boy.
So as it's parking its head to take a time lapse photo, that's when you can have some problems.
Okay,
but
but look at these horns.
articulating
on this.
mouth,
Yeah.
it snaps into place.
Get in
It prints
frame.
two
They're not okay.
two pieces
you
here,
go.
so that snaps in. Allows you to have some nice articulation on the mouth, and I love the horns. I like how the little twisted
Yeah,
horns,
60 horns are great.
and it has like some sort of mosasaurus feel with its flippers there. So it's a water dragon,
Yeah, Sea Dragon.
sea dragon. So nice sort of
Doesn't like
spikes,
fresh water, not a lake, not like.
but super articulated. Looks like the way they're doing their joints is with the these hooks.
Yeah.
Hook in. It's a very nice way to do that. On the bottom, you can see prints nice and flat, no supports needed. And
Yeah, very, very clever, articulated, print in place. One of our favorite print in places so far. We
So
have two of
cool.
them.
Yeah, because of course, once one of the kids sees them, the other kid is gonna want it too. So here is another one in. I forget what rainbow color this is, but it looks like a taco.
Does it feel like a taco?
Yeah, with the corn tortilla. That
Did you scale this at all? Or
No scaling since it is pretty much as big as the bed. And even offers an even larger one if you have one like a CR30, like the continuous belt printer. So there is a design that is included.
Infinite.
Not infinite, but just bigger than this, which I don't know if you can tell. It's pretty freaking big.
Yeah,
like when you stretch it out long ways.
Yeah. But on the bed, it curls up.
Yeah, it curls up like that. The mouth is separate.
Yeah, like
And
this.
separate. Yeah.
Yeah,
Exactly.
very, very strategic. So it's just about $4.
Totally worth it.
Totally worth it.
For
Very,
this
very
design.
beautiful
And it takes
by,
about damn near like 3 days to print.
Divine 3D Designs is the creator, so support them out by purchasing the STL and
This
printing
one
it
is so cool.
many, many times.
And it does float. They already took it in the pool.
Yeah, isn't that cool? Wish we had some shots of it.
Yeah.
Maybe later.
I know. I didn't get that underwater housing for the phone until later.
All right, so that's this week's Community Makes. Very, very fun stuff. We'll catch up on more Community Makes next week.
So cool.
But yeah, that's it. Cool. Any cool comments from folks watching live?
Neon is online.
Neon
Says.
is online. That's good. Thank you, Yanni. Yeah, Blinka Storage. You got it.
That's what I should have named it. Huh. All right, I think that's going to be
Yeah.
it for the
Make a neon
show.
snake. Cool. All right. Well, we invite you to come on and share your projects with the community and us on Show and Tell tonight at 7:30 p.m. Eastern Time. It's going to be hosted by Lamar and Phil this time. Shout out to JP and Liz for hosting last week. Maybe we'll host another week.
I'm going to say probably next week.
Yeah, and then Ask Engineer shortly after, starting at 8 p.m. Eastern Time. Tune in for a full hour of Lamar and Phil, new products, open source hardware, not the great search, Ion MPI, and it's a chip shortage.
We'll see what
It's a chip shortage.
whose chips it'll be this
Every
week.
day. Every way. Not RP2040s. Those are nicely and readily supplied. Sorry, I'm just clicking around. So yeah, we invite you to come in. You can get invited by joining the Discord, and around 10 minutes before the show, we'll drop in the link for folks to join in on the Discord. Cool. You got John Park tomorrow at 4 p.m. Eastern Time for John Park's workshop. Get some live building going on. Tim, Foamy Guy, on Fridays.
I think Scott is back.
Scott's back, you're right. Welcome back, Scott. Shawcroft, the CircuitPython engineer extraordinaire.
Yeah, he might be on Show and Tell, so definitely.
Yeah.
I think he was already on the CircuitPython.
Oh, he's got something to show off for sure. He's got a baby to show off.
Yeah, so he might be back to streaming.
Yeah, but Tim, thanks for doing
Yeah.
Maybe
I
maybe
think
this week.
they might like do the schedule switch again, but Tim is
Co-hosted
still doing it.
by Tim, or
Yeah.
maybe co-hosted by
baby.
Scott. That'd be cool. A baby co-host. Excellent. Well, that is going to do it for us. We do the show every Wednesday at 11 a.m. Eastern Time. I haven't gone through the whole slew of shows, sorry. Mondays, no. Sundays, Lamar and Phil. No. Lady Ada from Disco Lady on Sundays. And then Mondays is CircuitPython meeting.
And then Tuesdays,
And
JP.
then Tuesdays, JP's product pick of the week at 4 p.m. Eastern Time. You get up to 50% off select items.
Only during the live show,
Only
so
during the live
definitely
show.
make sure you are subscribed and get that hit that notification to get alerted when he comes on.
Yeah. Thank you everybody so much for supporting the show by getting more stuff from Adafruit, and you're supporting everybody. Not everybody's here in this photo, but there's a lot of folks that make this thing go. So we appreciate y'all buying a thing every now and then.
Speaking of buying of things, go and check out adafruit.com/new. to pick up all the awesome new things coming out.
Ooh, I need that.
I know, I want that now.
I want that cable with the magnets.
Some cool magnetic cables, some cool new iSpy cables.
All right, everybody's already saying like goodbye. Like, hurry up on your show.
Go to /new quick, because I'm gonna.
Look at this blinker. Really cute
Bye.
blinker. Just saying goodbye. Well, thank you everybody so much. We hope you guys make a great day, and we hope to see you in the show and tell tonight. Until then.
What was the other one we used to say? Make, share, repeat.
Okay.
See you next week.
Bye, folks. Woo.
Ow.